This video will be a demonstration of some of the new software controls at the microprobe imaging beamlines. This is not meant to be a comprehensive tutorial on how to run the beamline, but more of an introduction to some of the new features that have been implemented this summer to make data collection a little bit easier for everyone to do. So this here is Beamline 2.3 that you see. And we are looking at the basic setup of the beamline as you might approach it. We have the standard programs are all open at the moment. We have the Express software panel here for the fluorescence detector. There is the power management GUI here for turning devices on and off within the hutch without having to go inside. We have the data backup program here. For copying your data to the FTP available network drive. You may notice there's an extra entry in this program now to copy over the data logs and queues from the DataServe program. There are programs that we are all familiar with, MicroScan for collecting image data, microEXAFS for taking microEXAFS spectra and doing beamline motion control. And there's XMAP GUI here for looking at the windows and setting the detector regions of interest. One that's a little bit newer is here. This reads the volt meter panels and the ion chamber volts from those detectors inside the hutch. Since right now we are doing highly remote operations, and we can't always physically look at a lot of the instruments that would normally be to the side of the control station. So this is digitizing those controls here. And the new program, this is now the heart and soul of the data collection programs at the beamline. Instead of having the data collector for the imaging and the data collector for XAFS being separate programs, they are now tied together in a master data queue program. This also does a readout of the sphere current. Note we are not doing operations currently, so it's currently off, and the status is red, but normally would be up here at the 500 milliamps. This will also give us data collection status and has a bunch of email options for users and staff as well, and we will go through that a little bit later. So what I want to do now is really just highlight some of the major changes and updates that are fairly exciting. So here we are going to jump in and look a little bit closer at the beamline. There we go. Here is XMAP GUI. And here we are looking at the various windows that are and the regions of interest that are being set up for this detector. The real new feature here is being able to use the periodic table interface. I can bring this up. There we go. And this is exciting because now we don't need to memorize all of our X-ray energies. We can just click them in with the periodic table interface. I'm going to clear the work that was done here before. Clicking on Clear All. And now, if I want to add different elements of interest, I can just highlight on the periodic table and edit them in. So we can say, look at sulfur. When I click on it, it gives me the fluorescence lines and their information here, as well as highlighting where those lines will show up on my spectrum. If I had actually a full fluorescence spectrum here, it would highlight those portions of it there as well. I can then say, okay, I want to add the K-alpha line and click on K-alpha. And it adds it in. There are also sets of very commonly used lines that we have at the beamline here. And this now has, say, our most common overall sets, and it has sets for low Z, medium Z, transition metals on the low end, high end, and a common package of rubidium, yttrium, strontium, uranium. I'm going to click on the basic set here. And this will add in all of those channels onto my list here. Now, you may recall that we often need to put any elements that we are interested in doing X-ray spectroscopy into one of the first 4 channels. Note that this has been put in periodic table order. So if I wanted to note 1 or 2 or 3 or 4 channels for doing spectroscopy, I can highlight the element in the peaks list and say toggle XAS. It'll add that to the peaks here, and then look, it'll turn green here later on if I click onto a different element. I'm going to set both iron and manganese as my XAS list. And note here that this is in the order that we've clicked on them, not in the order of periodic table. So you can set the order of those first 4 channels very easily that way. When I'm done, I can say populate ROI. And if in XRF, the default here is to export those labels to microscan, not only will it populate the proper channels in here in the proper order. Now I have iron, manganese, and the rest of my channels. If I click and select check all, we will see those windows. I can also look into microscan, and when I configure my ROIs, we will see that it has already populated all the proper windows in their proper order here. And we'll have done this for all 3 data collection modes. And so this way we will never have, ideally, the wrong windows in your microscan. If you forget to change your windows in XMAP GUI and forget to change them in microscan and have the wrong ones. So this is very handy overall to have. It's a great interface. Now, if we want to actually, say, begin to add things to our queue, we can go to microscan. It has changed a little bit, but the basic functionalities are still here. We can still move around the sample. There's no sample loaded right now, but it is, we're looking at blank space, but we can still define an area. And I can add a scan to the queue. When I add that scan to the queue, you see that it shows up in our master queue program here. And all the information that we had here is basically transferred here. I can make another one. I forgot to add a file name, but that's okay. I'm going to say file 2 here. And I'm going to set a different scan area. So by hitting set scan area, I'm now going to draw a new one. And I can add that scan to the queue. There we go. And whatever is in the entry fields here, it always shows red there. And I can always say show queue regions here, and that will show the ones that are in the queue. One of the other nice new features that are here is that the wheel sample changer now, position 0 through 6, will always be reflected in what is being shown here. So this means the wheel is at the right position for S5. And if we move it around in any other program, it'll also be reflected here as well. Now, the nice thing here is that now since we have the master data queue program here, we can always click on one of these regions and I can edit them. So I can click on edit here, and now here is all the information that we just had. And I can go back and say, oh, I forgot to add a file name. I can call this file 1, and now save that. There we go, and now we've edited that in place. We can also do things to copy. If I left click, it'll create the copy in place. If I right click, it'll put it at the end. We can move these regions around by up and down, clearing all of them, deleting a single highlighted one, and we can even create new ones. The things that we can do in a queue are very common things. We can do like wait if we want to have a pause, do a time scan where we'll measure the counts on the ion chambers and the fluorescence detector for an amount of time. We can move any motors, do motor scans where we do a scan of the motor over a range and pick the high point, the low point, or a plateau range. A 2-axis motor scan where we do this with two motors and pick the ideal position of both. This would normally be, say, the stage X and stage Y positions, for instance. We can do a 2D scan This is not a image scan, but this is a two-dimensional, two-axis scan where you can go over the entire range of both motors and again pick a maximum or minimum spot. We can do a macro. This would be any of the macros that exist in the XAS program. We could run those from here. And for the new optics that we have being installed, we can do an alignment procedure and have it pick the best alignment, or go to one of the previous presets. So these are all different options that we can do. Now notice that you can't add an image directly. Those images need to be added from microscan, and you can't add an XAS directly here, but those would be entered in from the XAS program. We have a lot of great flexibility here. If we look at XAS, a lot of the information that you used to be able to see here, including the mono position, time, and scan information, is all now in the data queue program here. So all those status points are all right here. And we will now have all of the information regarding the data points, sweep time, time to completion, all being reflected for all the different modalities of data collection in this panel right here. We have our regions and our detector file, and we can, even if we're doing single ones, it will always ask if you want to add it to a queue. So we could say, take an iron veins here, and I could say, let's set up a queue. And this is going to be the same queue program that you're used to seeing here. But now, if we add a position, it will actually add it into this major queue, not into the XAS queue. We can take our current point here and say, add that point that we're at into the XAS. You see that it shows up here. And we could say, that looks really good. We're going to call it my data because we're not being very original. We could say that we do want 2 repeats, for instance, though, and all of these bits here are fine. We can now say, add this to the queue. So note here, there's not a start, but there's now a send button. Now, I highly recommend that we write plot markers if we were doing this in real time here. And you can also load queues that have been saved from, say, the microanalysis toolkit from your analysis into this part here to pass on to the master queue program. If I hit send, we should have it sent to the master queue program. Oh, there we go. It asked me that here. And it asks you if you want to reset the scan number. I'm going to say no. I'm just going to let it go ahead and do it. And there it's gone. And now, if we come over to here and say show XAS locations, it also will denote all of our XAS points on the map too. So as you build up your queue, you will see all of the regions that you have scanned for images, as well as all of the regions that you have selected for XAS as well. And now we see 2 of those in there. Now we can even come back and change these. I can edit this point and say, oh, I didn't want those to be overlapping, but I'd like to make that a slightly different position. And I can just change this by a couple hundred microns, 100 microns. And save. And now we come over here. We should see that it will update properly with the new point being down below. One of the other confusing parts in the old software was that if you change the wheel positions, all of these regions that could be on multiple samples would all overlap. That is no longer the case, and it will only show you the sample positions and XAS positions that are on the sample that you are viewing. Back here on our data queue, you can, of course, start the queue from the top. You can start the queue from the middle, pausing, exiting the current one and moving on to the next part of the queue, or aborting the queue cleanly. You can receive a whole slew of different notifications that you might want to be alerted to at the beamline. By default, whenever the beam is coming up from a dump, or whenever beam is lost, it will always send you the email. It will tell you when the queue is finished. You can also add queue start, or if there's an error in the program and it crashes out, it will send you that email for a queue error. You can also get emails sent to you for any action. So any line of the queue being started or finishing, or any scan. And by scan, we mean an XAFS or an image. You can have it let you know when the scan starts, finishes, or it's even 80% finish. This is very nice so that you can set this up so that it will alert you that you might want to pay attention to the beamline shortly if you are off having dinner or taking a nap. And you can fill in any of your emails or text as email message lines down here, and it will send those blasts out to those recipients. Now, the good news then is the staff will also get some of these messages as well, but mostly just ones related to the spear and the air. We won't get all the emails regarding all of your samples, so don't worry about sending us an obscene number of emails. We've made that more reasonable for us. So that is the biggest change. And when we start queue or do any operation, it will always take this queue and save it into your master data area there. So you always have a record of what you started, and it also will save a logbook for you of all these parameters as they are queued up in your entire experiment as you go along. So you can always track what's happening. Now, what we might have to worry about is, say, that we've measured at 12 keV here and here, but now we are moving down to iron. So we might want to say, well, I need to make sure that I move the beamline to the right configuration for doing the spectroscopy. So we can create the region here, and we can call the macro that we would normally use in the XAFS program. We can make a new one here with that, and we can look at the current detector will be, we can choose the detector that we are using in our system here, and the macro name. And here we see that we have sample presets, so that's moving the sample position to whichever area we want to go to. And we can also select, say, the move to iron macro that we've written to move the beamline configured to the iron position. And we can now save and add that in there. And voila, there we are at the bottom, hopefully. There we go. And now I can move this up in front of my XAFS position. Now note, if you would have had that in your queue set up here, it would have also transferred any of those macros automatically into here as well. In addition, all of the macros that involve sample changes, if you program that in the XAFS program, it'll transfer all of those properly here. It's always good to check, but it does a pretty good job. It's also made a running list of the current time of all your scan regions as well. So this, right here, these 2 scans and 2 spectroscopies with 1 repeat each there is now 2 hours and 43 seconds and some few bits to the end there. I think these are most of the really cool new features at the Beamline. We're very excited about being able to mix both imaging, alignments, and spectroscopy all in the same queue. And hope that you will enjoy these new features as well. See you at the Beamlines eventually.